Hi everyone, my name is Taku Mahuru, class of 2024, and I'm here to present on my topic, Mother Nature's canvas, colors in fossils and what they tell us. So there are three main processes that are involved in the process of fossilization. These are chemical replacement, trace fossils, and mold and cast. But the process that is mainly responsible for colors in fossils is the process of chemical replacement. In this process, minerals that are dissolved in groundwater interact with fossils that are buried underground. And over time, as the organic material in these fossils breaks down, the minerals replace the organic material. And because minerals come in a wide array of colors, it is only natural that these fossils also become very colorful. So for example, fossils that interact with the mineral phosphate become jet black in color, and fossils that are formed in areas rich with iron become red or orange in color. Right now I'm going to show you an example of a fossil that we have on display that is undergoing the process of chemical replacement. So what we have here is a piece of petrified wood. And while you would expect wood to be gray or brown in color, clearly you can see that this piece is very colorful. It has an orange bark, and in the center we can see some pinks, some blues, and some greens. This is because this piece of petrified wood was replaced with the mineral silica, and it took all the colors that are associated with this mineral. In fossils that you may have noticed in the past, you may have seen that they're not as colorful as what we have here. Well, let's head downstairs and I'll explain why that is. The process of chemical replacement, while it may sound so simple, is actually very complicated and happens over a long period of time. And it is dependent on so many factors, such as chemical reactions, how long a fossil is buried, heat, pressure, and so on. What we have on this dais are fossils that had only begun the process of chemical replacement, and are fossils simply because of their age. Generally, a fossil is defined to be anything that is 10,000 years or older. For example, what we have here is a direwolf. This direwolf was trapped in a pool of tar and asphalt, and the tar prevented scavengers from attacking the bones and inhibited microbial decomposition, thus keeping the bones intact. So, while this direwolf is not as colorful as the fossil that we saw upstairs, the dark shades that we can see on its bones give us a clue about the environment in which the process of fossilization occurred. Thus, the color is telling us how this fossil was made. This is in contrast to a fossil that I'm going to show you on the other side of the room in a minute. What we have here is a cave bear, and as the name suggests, this fossil was preserved in a cave. The cold conditions kept the animal frozen, but the dry conditions allowed water to sublimate out of the body, desiccating the flesh but keeping the bones pretty much intact. And as you can see, this fossil is lighter in color compared to the direwolf that we just saw. And this light color again gives us a clue about the process and the environment in which this fossil was formed. A common misconception that people have is that the older a fossil is, the darker in color it will be. Behind me are fossils which were formed tens of thousands of years ago, which are pretty much dark in color. And this is in contrast to fossils which were formed tens of millions of years ago, which are pretty much lighter in color. What we've learned today is that color tells us little about the age of a fossil. Rather, it tells us the environmental conditions and the process by which it was made. So the next time that you're in a museum, think about all the colors of Mother Nature's canvas.